Hello everybody, I am back for more work on the x86 instruction decoder that we started last week. I've been working on it as we get prepared for the stream, or as I prepared for the stream rather. Basically my plan to start off is to see if I can get the unit test library that I would like to use, see if I can get that going. It's utest.h from Sheerdom. Oh, it works at Unity. Cool. And yeah, the burst compiler seems really cool as far as stuff in Unity goes. So it seemed like a pretty nice little, like, incredibly simple unit test framework. I don't want anything very complicated because, again, this is like, it started off as a single .c file, no header or anything, because I'm, was just keeping everything in the one unit file. I have since then broken things up into a few different files. So we've got the sort of library code in here that's got the decode function implementation. The header has like the type declarations for the structure and enums, as well as the function declaration for decode. Debug is just where I have the print instruction function that I am working on right now. I have to finish filling it out before Clang will let me compile, since I have werror and wall turned on, and wextra and stuff. So like trying to get all the warnings I can and then treat them as errors. And so it needs me to fill out all the actual cases for this print instruction switch statement right now. So I'm going to just do that manually. I still haven't decided how I'm going to maybe automate that process. Certainly it becomes more complicated if you want to actually print out real assembly equivalent of the decoded instructions. So then that gets you into the very lowest level of a real disassembler. Obviously, it wouldn't be doing stuff like determining functions and finding where data references and control flow graph and all of that stuff. It wouldn't be doing any of that, but you would be getting a listing of assembly instructions that exist from one, in one stream of data. And that has some value, but it's certainly not, it's a bit outside of the scope of what I'm working on. I just want to decode to a particular data structure. So really what I want print instruction to be is to print that data structure. But right now we are just going to be printing the opcode name. And I think I would still want to use the data desk library that I mentioned on like my first stream, I think. Use that to automatically sort of generate this code. But I looked into it a little bit more sometime over the weekend, I think, and it's just a bit more involved to get that going than what I want to deal with right now. You basically write some C code that generates the C code, and you get like an AST that you can walk of the data declarations, and then you can use those declarations to generate what am I saying? To generate the code to do printing, or generate code to do anything, really. I mean, it's a very flexible system. It's just sort of a metaprogramming kind of system. But C is not the ideal language for doing metaprogramming, in my opinion. So I would keep it very simple and just maybe have code that knows how to print out the structure automatically, and deals with the enums automatically, basically. So I might do that before the next stream or at some point in the future, but not right now. I'm just going to keep manually adding each opcode that we've added into our enum of different opcodes, which shouldn't grow very quickly, because I think we've got a lot of work to do to deal with the new opcodes that we started on in the second stream. Those still aren't fully decoding properly, and it's a subset of those. So for right now, I'm going to just finish filling this out, and then I want to test that my like sample unit test that I created actually gets compiled and run when I do my make file. So yeah, that's what I'm gonna work on at the moment. Let's just add all of these. Do I have everything? I think that's actually all of them. Okay, yeah, and no longer get the warning about the switch statement. So let's see if compiling it works. Unused parameter in decode opcode 9x. And I don't think, oh, I'm on 10, but I bet saying, what was it? Opcode 9x. I mean, I'm not even going to use these functions. Is this function unused as well? Yeah, I'm going to delete this function because that's just not how I'm going to do it. I'm also going to delete 6x at some point, but we're currently calling it, you know what, let me just go ahead and delete it right now. I don't care. So we will do a break here, and that will, in theory, yeah, I just don't need, oh, you know what, but oops, I want to put the comments back in. Oh, but I already, can we do it this way? No? Okay. I was like, did I just kill my terminal? So everything, and then, oh, I see. Yeah, it was working. Okay, and then we just want we do this, and then no. All right, we'll do it. So what have I done? Hit some kind of okay. Does that work? Apparently I hit some command in Emacs that prevents it from working. And I don't know how to get out of it, so that's fun. Okay. I lost those. Git restore stick. Okay, so let me try that again. I'll just do this set of lines. Okay, so all right, and then just do ugh. I should be better at Vim to do this, but I'm not. So all right, just want to keep these comments for later. But we're still going to break and delete this function, and we will do the same thing here. And then 0, what is it, 1001? Yeah. I'll delete that function as well. Let's double check what we've got. Just that, okay. So we don't need those anymore. And let's see if we can make stuff. Okay. My make file is bad. So it should do build and then test. And test should depend on this. But I guess the default doesn't work. So we got to do CC, think like that, C flags, and oh, what is it? Something like that. Practice, ptrace, makefile. Yeah. Okay. Let's give this a shot. Syntax, your new line. Why is it not like that? Is it because I have the dollar stuff in there? It's because I'm in a template. Let's look at the documentation again. I'm pretty bad at make. Maybe the beginner thing is really helpful. Okay. They have like Automatic variables. Name of the target. Ooh. So maybe I just don't need the, oh, I guess I don't need the two double, or the double dollar signs because, no, I need them here. I don't. I'm going to change this one because that was inside of a template, so I needed to escape the dollar thing. Okay, cool. So this now made the test. We got a failure because I wrote the test in a way that makes it fail. And so if we look at test, cert true 0, now if we cert true 1, now it passes. Cool. Okay, so we're in a position to actually write unit tests. So if we say what do we want to say? How do I have that? And then what would be like add EAX? I don't know that I can do the add EAX one. Let's go back to the docs. Let's see what we have. I was looking at the table, which is makes a lot more sense now. I mean, there's so many like abbreviations that I would need to keep looking up, but this table makes a lot more sense, and it really shows how they pack as much in as they can, and where instructions are how to put it, correlated between different byte values. So we've got a bunch of AND options here, a bunch of ADC or add with carry, a bunch of AND, and a bunch of XOR. Like these are clearly similar-ish instructions in terms of how they're encoded, with just a difference in the upper nibble. And then I think we've got a similar thing in this chunk here. Yeah. So that is, basically the set that I'm working on. So it's nice to be able to see those in a table where it shows that they are grouped together. I can't really highlight in a nice way for what I'm trying to show, but it's this, it's like a block of instructions here, and versus maybe pop goes across the whole spectrum here, stuff like that. So let's look at appendix B though, because that's what I was using. We want the instruction formats and encodings for 64-bit mode. So if we want to do add, yeah, so other than add EAX with an immediate, which again does get encoded a little bit differently, and I don't think that we're working on this encoding yet. We really need to say, maybe we could say add EAX EBX, and that's something that we can deal with in our current encoding. So if I do Rabin, I don't know if that's the right. RASM 2, then a x86 maybe, B32, and we say add EAX EBX 01D8. So let's double check what that would look like. So that's this one for some reason, or no, it's this one because we're 1 for the width being 32-bit, I guess. You can double check that logic in up here. So if W is not set, yeah, then if we're in 32 bits mode, whereas if we are in 16 bits mode, we would have to do AX and BX, which will be the same. Why is it not 0, 1? It's a bit weird to me. Should still be 0, 1, but maybe and these are not D8, so I don't know. But if we do 0, 1 D8, that should use that. Okay, then we can say decode input and output. Cert, can I say assert equal? Yeah. Cert equal output dot opcode is op-add. Guess that's true. Can I say just to force that? I mean, I don't know. The enum typing stuff is really more of a C++ thing, so yeah. So we say make all. What happens? Undefined reference to decode, but we've got decode in here. Am I not including? I've got it right here. 86 deck. Maybe this is again a make issue. Name of the first prerequisite. So we want caret. Okay. So now we have test and 86. That somehow worked. Doesn't seem like it should have worked. Can we check this to that? That failed, yeah. Okay, now granted it's not deeply helpful, the output that we get, but I'm gonna deal with that later. So why does that work? Is that just because we set the right opcode here? Okay, that's fair. Cool. Now, okay, so we've got some tests running, or one test at least. Add all. I'm saying add all opcodes debug print. Okay, then get ignore, yeah, and 86 deck test, and then makefile also we should add x86 dec test. Cool, deletes both of them. Okay, so then we have updated our code. Okay. All right, so the first thing I want to do actually is update our instruction structure, and I want to have a new structure type. Which is a type of operand, and it's going to have just be verbose about it. OT, I guess, for operand type. This is one of the things, the lack of namespacing in C is rather annoying to me. In fact, I probably should have said, let me just write this in C++ and do it in C style, but have namespaces. It's such a... Anyways. All right, so do we want to have a different type for when you have stuff like mod RM and SIB? I think I'm going to leave it as is, and we will have an operand type, and then we'll have a uint. So we'll do a uint8t for register. Can't call it that though. Have a uint32t for memory, uint32t for immediate, and we're just gonna have, I mean, we could make this a union, I guess, and really complicate the situation. Do I want to do that? What do I call it? Union value, and it could be a struct. Can I do like do it this way, uint8t reg. So I want to be able to encode all of the stuff that goes in with mod RM and stuff. So for that, we want I guess like the first register, the second register, and oh, but it could be displacement and stuff like. So let's see. Yeah, and that's a second 16 bits, or 32 bits in this case. So is a union worth doing? Just trying to figure out what's a good structure to encode all of these possibilities. So if we have SIB, then SIB is a little bit more understandable, or a little more structured, I guess, because basically we're going to have one register for the index, another register for the base, and one option for the scale itself. So I have the index register, the scale value, and then the the base register. And that can all be single bytes. So, and there is also, well, I mean, these will just come out differently, but these need to be with a displacement and EBP. Ugh. So the possible things are, we could have an index and a displacement up to 32 bits and a register reference. There's just no, I mean, the way that I'm thinking about it now is like, even if I split all of these out in different fields so that it's easier to parse it, I mean, it's basically still decoding it. The way to interpret it, to know, okay, we need to look for the scale and a displacement and know to reference EBP, is just like, we need to find a different way of encoding what addressing mode we're using. Like, the complication continues beyond the decoding, basically, because then you have, how do I use this structure in order to understand what the instruction represents, even after we've decoded it into a somewhat nicer structure. So it's all manner of fucked up, I guess. Okay, so we can have a register on one side, like, what does add 0 0 mean? So like, if we go back to RASM, do we need to put a dash D? So we do have 0 0 0 0, right? So this says the address is the dereferenced EAX. And if we say 08, then that moves the second register. Yeah, okay. So whereas we have 09, then it's ECX, ECX. Is that accurate? Okay. So this register up here is going to be a second operand. And maybe we make that a more simple option. And then this side, is a displacement. And then, I don't know. Okay. It's just a single byte displacement. Yeah. So we would need 80. Oh, and it'd have to be. Okay. Then. So encoding this set is relatively straightforward. Operand 2 here is going to be a it just is going to end up being a register one, OT register. And operand 1 is going to be I see. So we need to be able to refer to one of these registers as a like dereference, and then also have a displacement. Okay. So this will be I don't even know about this situation. Is it just what do we have for what does it look like if we do C0? Okay. So this set is also pretty straightforward. Or this is the one that's straightforward. Both of them are just operand type register. And then we'll have a UN8 that represents the register. This one, or all of these, need to be, except for these ones, which will be separate. All of these are going to be a operand type mod RM, I guess I'll call it. or we could call it like reg displacement or something, because we can just think of these as having a displacement of 0. We'll have to deal with this one a little bit separately because it's going to have a displacement that is without the register part. Maybe I'll just make 0 be like register none in the register types. Oh yeah, we've got reg unknown. Let's do this as -1 and reg none will be 0. Okay, then so we can have register none paired with a 32-bit displacement. So all of these will be a combination on this half of the opcodes, or sorry, operands. On this half we will have a uint8, an 8-bit identifier for the register, and then 32 bits for the displacement. We won't use them all. I mean, it doesn't matter. Basically, if it's a disp 8, it'll just be 0 through 255, but that's fine. Then we'll also have a SIB mode. So let's do that. We'll have an, sorry, I want to delete this. We'll have this as operand basic, or no, we don't need a special thing for that, but we do need operand mod rm, and that will have the register. It will have and we could probably make this an int32 because I think these are positive or negative. Let's go with that for right now. Sorry, and this is not an int30. This is going to be a register. And we'll call this. Okay, so that's that type. And then the SIB will be scale, and so we'll have register scale uint8t for index. Sorry, this will be index and this will be scale. All right, so these are our varieties. So we can have a register reg, a uint we want to do, let's do it as uint memory get, and then also operand mod rm. So these are the options that we have. Yeah. Declaration does not declare anything. Do we put it down here? Okay. Think? No. Ugh. I have forgotten the union syntax, apparently. Yeah, we put the name up front. So, what is the issue? Why are we getting... Declaration does not declare anything. Can you show me a union inside of a struct? Yeah, but it doesn't... Can't I name the union? Or no? Apparently not. Okay. Fine. And I mean, I guess that doesn't matter. Okay, so then for this we will have operand 1, and like in theory we could have multiple, or we might have 3, but I'm not going to worry about it right now. So obviously this ends up being a pretty large structure. These will probably be 32 bits each, and then this will get padded. So we'll have 3 32-bit values for the size of our union, and then a 4th for the type. And so each operand in our instruction structure is going to be, what, 16 bytes? We'll have 2 of those plus another 32 bits. So we'll have, what, 36 bytes per instruction, I think. But I'll live with that. Okay, so then let's create the test, or add to the test. Assert equals, then let's do a simple one. C0, 01 C0, output dot operand 1 dot type. It's going to be we can just call this opcode, right? OT register, and the same for operand 2. And then, oh, we don't need the enum part. We can say assert equal output dot operand 1 dot reg is register reg EAX. So, I mean, that's everything that is represented in this bit of assembly code. So I think that's all the stuff that we might be able to get out of our instruction structure for this one. Then under basic, so now we need to actually be able to decode. If it's an immediate, then operand 1 is that. We actually want dot type equals OT immediate. Expression expected. Can't I initialize like that? Oh, I probably need commas instead. Still doesn't like that, huh? Why is that not valid initialization syntax? Whatevs. Also, shouldn't it be operand 2? The immediate. Oh, I was able to get the immediate flag, so it's actually. I guess we are parsing this one out. So right, and that's we only have the one operand. And let's go ahead and do ot none for. We'll make that 0 so that when we initialize it, operand types are none. Register type is none. And the opcode is unknown if it's all 0. So when we initialize an instruction structure with all zeros, then we get an opcode that is op unknown, so we can detect that and represent it as an error in whatever code is using our output structure. And our operands have OT none. I mean, would it be better to make them unknown and then none is like 1 or something? I'm gonna stick with none is 0, because if the opcode, yeah, so operand 1 is OT immediate dot type oh, and it's not dot value, is it? It was dot immediate is okay. Then that seems fine. Should I put the size of the operand into the output structure? I'm gonna leave it off for right now. And I mean, that's super dependent on how you would want to use this structure. And I think for right now, I don't need to care. Okay, so we could get an immediate working actually. So let me, yeah, I need to just do that. So I can actually make this work now. Okay, so why can't I do this. I guess I need to actually copy. Is that accurate? It won't just copy the whole structure for me. Let's think about it. Well, let me do that. I honestly am pretty unsure if this is going to do what I am wanting it to do, which would be generate assembly code to copy the entire structure. We'll find out. Okay, so one thing I want to check is actually, does that swapping work the way that I think it does? So if we have 3, so let's do mod rm C8. It's going to be EAX ECX, and then 03 C8 is ECX EAX. Yeah, so it does swap those around. So we could also test that. So I'm going to make this a little more interesting. Go with that, and then ECX should be that one. Let's do reg1, reg2. We'll say reg2, reg1 for this. And this one will be ECX, and this one will be EX. And do we also want to test immediate? Which is switch back. That one's going to be 4, so 5, and then thing. Try it that way. Oops. So, right. 05 and sorry, 04, and then AB, let's say. So then, oh, but if it's 04, if it's an immediate, then we know that right, it adds to AL. Okay, so, well, let's do it this way, and that one's going to fail. I haven't been doing anything that, oh, 2 of them failed. Because I didn't fix this one to say 3 instead. Nope, 3 tests fail. 03C8 should be ECX EAX. So we're failing on line 14. Okay, fine. This one, I need to fix the code before it'll pass. Also failing on line 30. So we got the wrong register in that one. Interesting. We expected 12. That's going to be 0, 1, 2, 3, 4. Why did we expect 12? 5, 6, 7, 8, 9, 10, 11, 12. So we am I writing these in the wrong order? I guess so. Okay. Let me double check. What? Why is that unqualified? No? Just like that. Okay, so on 30, so I guess it's not doing the copy the way that we expected. So let's go ahead and do that as a function. We'll pass them in as pointers. So we'll say operand temp. Oops. Temp dot type equals left dot type. Okay, yeah, I'll get to that in a second. So, and I think we need to do a switch. Is left. Yeah. I guess we can do let's see. Did I call it? Yeah, I did call it displacement. Okay, so if it's OT none, then we're good. So register, then temp.reg equals left reg. Let me do this all like one line. Now, if it's one of these structures, then we gotta go in and say temp.mod rm dot reg equals what is this? Label it endo. Oh, okay. It's just some leftover broken stuff. Okay, so then again we need to we want to do it all in here. I feel like I mean, do I like this is me trying to do a type safe thing, and maybe it's also I'm failing to understand how to do C code properly. It just feels very verbose. The non-type safe way to do it would be get it as a buffer that is the size of, you know, just do like a mem copy kind of thing, since we know that they're same size. I don't know, and that would certainly be more performant, but I'm gonna skip it for now. So if it's OT none, then write type equals temp.type, and or sorry, left type equals right type, and then right type equals temp.type. Do we want to do it as a second switch statement, or do we want to like make all of these complicated? I'm just going to do it as a second switch statement. It's kind of annoying. Maybe we'll switch it later. So OT none still needs nothing. Then these are all going to have to be multi-line, I think, because we're going to say right.reg equals temp, sorry, right. Wow, I'm just okay. Then yeah. I mean, yeah, because I do want to actually do the swap. I was thinking for a second, like, what if I just had a flag that said whether to read, which order to read the register the operands in? But I think I don't want to push that complexity onto the user of the data structure. I want them to know operand 1 is always going to be the one that would be listed on the left-hand side in Intel syntax, at least, and just not have to worry about it. Like operand 1 is always the target of the data, I guess, in the for those instructions that are writing to some kind of register result or writing to a memory. Like it's the place the data is going to, I guess. Then oops. All right, so those are working so far. And can I simplify these? These are going to be left. To left/right. Yeah. What do I want to do? On this side, the left goes, no, I want to first do temp. Let's double check because I did that all in bulk last time. Left gets right, and then right gets temp. Left gets right, and right gets temp. And then left gets right, and right gets temp. Okay. So I'm just going to say swap operands. Inster operand 1, address, and address of inster operand 2. Still doesn't work. And it did recompile it. Maybe not. We're not handling that in in the debug. So that, yeah. So all that swap stuff was not what was needed. Just make it very obvious. Okay, so those are still failures. Maybe I'm just still not parsing the mod RM stuff properly. Wow, I really hope that I didn't just go do that swapping stuff for no good reason. So if the mod bit is 1-1, then RM is going to be what our register is in the ACDB SP SBSD, or sorry, SPBP SIDI, which is ACDB, right? ACDB SPBP SIDI, yeah. So, I mean, these are, we're going to have to special case these for sure, but at least this bit, we should be able to read those registers properly. So, that is definitely confusing. If mod is 11, then operand 1 is regs. Maybe it's this part that's wrong. Okay, first thing I'm going to do is go back to the normal swapping code. So operand 1 is the reg part, which is up here. So if we have C8, then operand 1, according to our code, is going to be CX, and operand 2 is going to be from RM, will be EAX. Right? So let's double check that. 01C8, is that accurate? Yeah, so I just have those backwards, I guess. Okay. Then what is wrong here? Declared identifier RR. Oh, take out the W part. Okay, can we just comment out that function for the moment? Okay, so I didn't need to do all that swapping stuff. The compiler was swapping those structures, memory copying them as I wanted. So it was just the other element where I misinterpreted the table, and if we have this set up, then RM is going to be the first register. I wasn't actually testing it against any existing piece, and that's my bad. I mean, maybe it's arbitrary. I don't think it is arbitrary actually, but it's like, I don't know where it is discussed which of the operands are which side, I guess. So yeah, I don't know about that. Oh, you know what? Because it'll be mentioned down here, I guess. And maybe that means that it's different in different ones, but this is apparently, this is going to be the RM, and this is the reg part of the mod RM. So yeah, that makes sense. Okay. So we should have both of these two working, and we were able to see that. And it would be nice to have more comprehensive tests, but for now I'm going to do like enough of a test to feel like it's working at all, and consider how I would write a more comprehensive test suite at a later date. But this feels like progress. I can't, like, we are actually getting meaningful instructions decoded. Okay, then, and these are 2-byte instructions because we've got mod, and yeah. Then let's look back to the test. So this one is failing, and what we want to do is have this be, oops, that's going to be an immediate, and the value is going to be 0xab. And then the type on this one should be none. So we don't have a second operand. I felt like I needed to do more to the code to make this work. But not reg, but immediate. And int. That work? Unterminated macro-like function. Well, I mean, it compiles now. I think it's spurious error. Okay, but it's still failing. Maybe is the immediate going to be unsigned? Probably not, right? Like, let's look at what this instruction would be. 04 AB. And no, it is unsigned. Okay. Can we do it this way? But still, okay. So first off, I need to fix all of these assertions, except for this one, which I will unfix, I guess. Because I want to just do it all at once. Then, like, does it mention that in the docs for cert equals? Yeah, but I mean, shouldn't it mention, let's see. Oh, there's an expect version. Okay, interesting. But it doesn't mention. All right, well, turns out that expected is going to be the left-hand side, I think. Yeah. So right, or we just don't want that. Okay, then ooh, how do we want to do that then? It's not. But we do that all the time. Okay. Why does that not fit both of them? Oh, and then we want the, okay. Then we want to replace it with a cert equal, paren, open. Yep. Okay. So what did we get in the immediate? We say, is it a different value each time? Yeah, so we're just getting junk data in there, I guess. Is it at least, no? Oh, okay. I see, maybe we need to do this. No, wow. We can't promote it to UN. This shouldn't be necessary. I guess it is not. Oh, but we're doing the, oh. No, because this should be immediate 8, right? 04 AB is fine. Yeah. Oh, and right, that's the thing that I needed to fix. So, okay, but I need to and we need this to be AL. Okay, we'll fix that later as well. But it's, I mean, it's still failing on the first one. So, and we could switch all of those to expect, I guess. What am I missing? I see there's somebody watching. If you have any thoughts on what I am messing up here. Oh, the chat module is broken. I don't know if you're saying something, I can't see it, but let's see. Yeah, just having difficulty coming up with what is causing, I mean, the values that we're getting are changing on every run, so it's like reading bad data, or, you know, it's reading out of bounds. So what could it be? It's an immediate, and we want to, I don't think this is going to help. Well, that's weird. Why are we getting that on line 17? Oh, okay, so it was just, but we should be setting this whole thing like the immediate in both cases should be set to a like should be nulled out, and then basically the D word for the immediate should be, the high 3 bytes should be 0, and then the low byte should be whatever the 1 byte is. But it seemed like we were not necessarily setting the other bytes. Because we're just getting nonsense in there. So we say UN32T. Right, like since it's a pointer to a UN8, that should come back as a UN8. Not that I need to put in a temp variable, but still. How is this? I'm having trouble visualizing what the assembly code for this is. We are setting immediate as a 32-bit value, which is whatever that is ended with FF. So it should be setting it as, can we do it this way? And temp will just be no. What am I like? Operand 1.immediate, not a 32-bit thing. It is. It's the whole thing. I mean, it's larger than that, but we should be able to read the immediate value. I don't know why it thinks it's never used. I guess. Yeah, I don't know why it thinks it's never used. Okay, now it doesn't anymore. What am I like misunderstanding? Because it's a union or something? Well, okay, so let's say, we set it to UN18, right? It's gonna pass that one. Now, we go ahead and make a 32-byte one, which needs 05, and then CD, EF, and 89. Then it's going to read that as a little endian number, I guess. So we need 89 EF CD AB. And that one, 130 is failing. Expected. Okay. And now if we get those 32 bytes, what am I doing the wrong order again in the does need if W right is if not W. Okay, Jesus fucking Christ. So like spending so much time trying to fix a thing that's not really the problem. Okay, but why did it get the wrong value that time? Oh, because I typed this in wrong? Okay, geez. Can we do it this way? It's gonna complain. Uint32t. Right. Cool. Wow. My programming skills are just feeling top notch right now. Okay, so then we need to fix the actual register. Is it the same for all of these? So we've got add and ADC. Let's go ahead and look at that table again. Like 1, 2, 3 byte opcodes. So add ADC and XOR, as well as OR, SBB, sub, and compare. And ADC, or add ADC and XOR, then OR, SBB, sub, and compare. So ADC has it as that, add has it as that, and has it as that. Compare, yeah. Where is OR? And SBB sub is in here somewhere. Sub and XOR. Okay, so all of them, when you use this form, the operand 1 is going to be the register, and so this is actually operand 2. Okay. OT register, and reg AL. Not AL, right? But yeah. Okay. And so we need to swap these around. No, this needs to be 1. Okay. Be 1. All right. So we have essentially 4 different instruction formats for add working right now. And we can check several different like it should work for all of those that I mentioned. Add, XOR. I guess I can switch them up. So could do this one as and, this one as XOR, this one as sub. And so for and, we want the high byte. It's going to be, we're looking at 2 in the high byte, or not 2, but 16 or no, 32. So, or yeah, in the high nibble we should have 2. And let's go ahead and change these first, and then I can make sure that I'm getting them. Okay, so our add and our and are working. Then we need XOR and sub. Just sort of, again, not doing a very comprehensive set of test cases for now. I'll have to do some thinking about the right way to go about that. So it's 2 and then add an 8 onto the low byte for sub. That makes this B. Yeah, okay, and then XOR is 3 in the high nibble. Okay, cool. So, I mean, again, we're still not even getting 1 for each of the instructions that we can decode, but we have a few forms that we need to keep working on. So we've gotten these 2 forms, oops, just these 2 and this one. And the next easiest to work on are these, where we need to pull out the RM reference based on the mod value. Okay, so we're back to that business. And these very much do not follow the pattern that is more widely followed of A, C, D, B, SP, BP, SI, DI. So we've got BX plus SI or DI, and then BP plus SI or DI, and then nothing plus SI or DI. And I think I am failing to be able to encode these actually. Ugh, okay. So an RM setup needs to have 3 register values. So we got 1 and then the added. Or rather, it needs to have 2 register values plus the displacement, because the RM operand is just going to be this side. Okay. Okay. So let's call this the base and index. Right, what is the Wikipedia page that mentioned it? Source and destination index, right? That's what they stand for. Yeah, let's see. Do they mention? Highlighting is more annoying than it needs to be. Yeah, I don't know, but I think it is source and destination index. So I'm going to call that index, and then base and index, similar to how we have scale, index, and base in the SIB. I think they function in a similar fashion. You have your base register, BX or BP. And like, again, we could take the time to make a smaller enum for these because there's only a couple options, but I'm not trying to have my representation be particularly compact. Okay, so let's see if we can work out how to do the two yeah, okay. This one is just a display. I don't know. But this is for 16-bit mode. So I'm going to skip this because we don't really have support for 16-bit mode in... Oh, maybe that's why I went with the single register plus displacement. So, okay, let's go that route then. We are going to... It is going to follow roughly that same pattern, but not quite. Because SPBP, we're going to be treated a little bit differently. So, okay. Let's just keep the one register then. But obviously if we did 16-bit for this as well, we would need to track that. Let's do another RN bits to enum, right? That seems fine. Okay, then I'm gonna do it because it's so different on 16-bit. Then we're gonna do a specific function for the 32-bit version. W, does W come into play in this? Or rather, how does W come into play? Maybe it doesn't. I guess we can try it in the radar disassembler, or assembler, I guess technically. Like they have the W bit on there. So let's look at this instruction. Register to memory. So that'll be a 1 or, sorry, it'll be a 3 or a 2. And the mod being, let's see what we can get. If we just want ECX, then we want a 09. So let's do 2. Let's add CL. Okay, so that just, but it does a byte version from ECX. I see. Okay, and then 309. Yeah. Okay. So that determines what the destination size is, and whether we are dereferencing for a byte or a D word. But we're using the full EAX register in either case. Oops, I was already on the spot that I wanted. Okay, so do we, I guess we can use the same and we'll just special case the ones where it's going to be something other than the standard. Okay, so down here, if mod is 0, then RM, we want can we do this for all of them? I think that's probably true. Because I think we also have, just double check, and we can swap it. So we just do a 1 or a 0 on this. Then that just swaps the order there, right? So, so we'll always say instruction 1. If we didn't have an immediate, then instruction 1 is a register, and its register size is, right, and if we do this as 0, yeah. Register size is W based, and is it the RM or is it right, so wait, okay, so register, let's see. If we have the flip bit on, so sorry, if D is, or rather this is D is 0 on these two, then right, this is the immediate flag. So, right, D is 1 and 0 there. So if D is on, then we have swapped away operand 1. So maybe I had the right order here. Before. Right, because the register 1 is coming from RM in these. Or sorry, that's coming from the reg side. So yes, operand 1 should always be coming from reg. And then I guess we want to invert that. So if D is 0, then operand 1 becomes, yeah, that's the issue, because it's a 109 or a 309 for the direction. So if D is on, then operand 1 remains the reg value. Operand 2 is the RM encoded thing. Okay. Pretty sure that's true. If we wanted to do 8, 9, or let's do 4, 9, and then add a single byte. Yeah. Oh, God damn it. Okay. So operand 1 is always the register. In this case, operand 2 is the in this case operand 2 is also register, but in the first case operand 2 type is OTR mod RM, and see this again. So the register in mod RM is still going to be, with the exception of 100 and 101 bits. If RM or I guess let's see, that's going to be 6. So of those 2 bits, and I say what I need this to be B. Okay, thanks for that warning, Clang. Yeah, so if we just AND those 2 bits and it is 1, 0, then we'll do something else. But you know what? I guess I do want two separate. $100 is SIB. So oh no, it's still a mod RM. So, but we have operand to dot reg equals ot none dot sorry, mod RM dot reg, and not ot none, reg none, mod rm dot displacement equals uint 32t ix and s, right? We've already incremented it past this byte. Oh, okay, so we're going to read the displacement after mod rm. I'm trying to avoid actually modify. I mean, I've got it const, right? So I need to not modify it. Okay, then, and that's an int 32. Else, it's going to be just a single register. Right, okay. Reg, oh no, then we want to call reg bits to enum w, but we want rm. Okay, and displacement's going to be 0 in that case. Okay, so we'll deal with SIB later. I don't have a good story for that at the moment. And I think we're going to do a similar thing here. We can go ahead and set this as well up here and not repeat it everywhere, because we'll just override it for the one case where it's not. Or no, we start with our if statement, right? If, in this case, we just have one special, which is 100 is SIB. Okay. So 2.modrm.reg is reg bits to enumw, rmw size 32, and operand 2.modrm.displacement is equal to +1. Did we need to? We didn't need to do anything to like upgrade that to uint32, seems like. Okay. Then that's all of those cases. Because again, they follow the same pattern, which is helpful. And we'll do the same thing, but have a 32-bit displacement for this option. So same deal here, but this one is going to be in 32T. Oh, and I guess I should say in 8T here. I don't know that that matters. But we'll do it anyways. Okay. I think that covers all of those cases actually, except for the SIB ones, of course. Yeah, moving along reasonably. So let's write some tests for it. I really need to get back in the habit of writing the tests first. Let's do SBB on this one, and do OR next, I guess. So we want mem to register. We will repeat this test structure. Our input, let's say mem no disp. And I don't know what the limits are on how I can write this. Does that break it? Looks like it. Okay. So we want a 1A Reg 8, I guess. Not really being very meaningful with the register sizes in these, except for the one where W defines the immediate size. And I guess it is AL immediate 8 there. Okay, so if we have memory reference with no displacement and a 8-bit register, then let's see, the W bit being off makes it the 8-bit. Okay, so is that accurate? Yeah. So no, sorry. If it's off, okay. Then we have a 1 and A. we'll encode our SBB with memory to register, and now we need certain mod RM value, which we want a no displacement one. So let's pick one of the ones over here, because we've been doing a lot of AX, CX. So let's do DX and BX. So 13. That should have the register is DX. And boy, need to like have bookmarks. I don't know if I can put bookmarks in these things. So if we're doing this first one, memory to register, then EDX is going to be the register, is going to be operand 2. And this one's going to be the mod RM. And what are we going to have? The register was going to be EBX. And then the displacement should be 0. Okay, so now we can do, let's call this disp 0. And we'll do a disp 8, reg 32, just sort of some variety in it. And that means that we've got a B instead. Although, do we still want SBB? I think we want OR for this one because we haven't done any with OR. So OR is going to be a 0, and then we'll have 0B. Or 09, because we are, no, because we're still doing memory to register. Okay. Mem disp 8 to reg 2. Let's do it that way, I guess. Yeah, 0B, and then what do we want for our mod RM? Somewhere in here, we could do CH, or we're gonna do 32-bit still. So, right, because it's the register B. So we'll do EBP and DI, or let's do, oh, sorry, I'm in the wrong. So we'll do EBP and ESI 6E. So up here needs to be SBB. This one's going to be OR, and register 1 is still mod RM, but the register is, as I said, ESI. And the displacement, we need to add a byte for that. 55 or 44. Oops. Do it that way. Yeah, do I need to might need to make that. Okay, then I want this to be or do ADC. And we've got add and XOR sub SBB ADC. We'll do another one for compare, I think. So now let's do 32-bit with register 32-bit. That's fine for me, I think. Okay, so a 32-bit displacement for EDI. So we haven't done that one yet. With ESP, A7. And we'll get that first byte going later. Let's do it that way, 4 bytes. And the register with it was, as I said, what, EDI? And this one is going to be ESP. And we'll need to figure out, and the opcode is going to be ADC. Before we switch back, we'll do compare. Oops, how did that happen? All right, and let's pick another random one. This time, though, we are going to swap them. So operand 1 will be the register, and we'll make it a 8-bit register, and we will do an 8-bit displacement. Or no, let's do this one, right? This is an interesting one. So I don't even know how that gets, like, is that the displacement from RIP? I guess we should, like, why don't I go ahead and encode it, and then we will figure out what that actually looks like when we run it with the radar assembler. I don't know what that instruction looks like, because there's no operand that is. Oh, you know what? You might not even be able to do this one swapped around. Maybe. I guess it's still, it's a memory value, so if you compare it, yeah, that's fine. Okay, so let's see. We want this one with, which haven't we done on this side? I think we haven't done, I think we just did ESP, right? With A7. So I think we technically haven't done EDI. Yeah, so 3D. And we want this one to be reg 8 mem going to refer to it, because the other ones sort of assume the mem means. Why don't we do without the word mem, I guess. So reg8 and disk 32. Okay, so then first thing is we need to swap the order here. And the register is actually going to be EDI. Then the RM is going to be the second one. And what did we say that was going to be? It's going to be reg none for the register and a specific displacement of A1, B2, C3, D4. Okay. I see. Okay, so then we just need to go and get the right values for the first byte for these. So the first one we're looking for, is ADC, and then compare and then OR, I guess. ADC, we're doing mem to reg and 32 bits for the register. So WB on, so it'll be 1, 3. And then the compare is reg to mem and an 8-bit register. So W is off. So it's going to be 310, 3A rather. Oops. And then the OR. Lastly, it's going to be what did we say it was? Mem to reg and 32-bit. So 0 and A, sorry, no, 0B. Is that, oh, I already did that one, I guess. Well, let's double check these before we run the tests. If we do 0B6E44, that is OR with EBP. No, this is all wrong then. Did I just not fix this register properly? But this should be register to memory. Oh, sorry, that's going to be not 0B. Where did I get 0B from? I must have put it in there and just been wrong about it. Or I switched around. No, I don't want register to memory. That would be 9. Oh, I am misreading this. So memory being the destination. Oh, okay. So memory to I think this is going to represent not from to, but to from, like the order in Intel syntax, I guess. Yeah, that's just what it's going to have to be. So I think we maybe need to fix the SBB one as well. And then the other ones. Let's go to SBB. So if we are doing memory destination register source, and that's register to memory, which is 1, and then 1.8, because we want the W to be off on this one. Okay. Then, and let's double check that. 1813 is SBB EBX with no displacement and DL, right? Because it is a 8-bit register. I'll need to fix that on this one as well. It's just going to be DI. I think. We'll see in that in a second. Okay. Then the OR, we want, yeah, I need to go back up to OR and fix it, I think. So for OR, we wanted register source to memory destination is going to be 0, and because we wanted it to be 32 bits, it's going to be 9. So we do have the 09 now. Okay. So 096E44 is going to be ESI plus 44 going to EBP. Why is that EBP? I'll have to check that out. Okay, and then compare. We wanted a memory source to a register destination. So memory to register is going to be 3, and then our register was 8, so this will be off, so 3.8. Okay, and let's see what that looks like. 3.8, 3D, A1, B2, C3, D4. Okay, so get the byte at that. They say displacement, but I guess it is just a fixed address in memory. Yeah, okay. D4, C3, B2, A1. D4. Good, okay. I have a issue with writing this wrong. And then it's not DI, which is confusing. I am reading this table wrong, I guess, because all the register parts are not what I thought they were going to be. And this one needs to be the other, and wait a second. So that's a, no, that's a memory destination. So did I read that wrong? memory with register. That's yeah. I do need to. I did have that right. It's 3A. Confusing myself a lot. Okay. So and then ADC, and then we'll go back up and double check why the registers are not what I thought they were from the mod RM settings. So this one we wanted a register source to a memory destination. So register to memory. We want this guy. So it's going to be 1, and then we wanted the 32-bit register, so 1 1. And let's try that. 1 1 A7 1 1 2 2 3 3 4 4 is going to be mod RM with EDI plus 4 3 2 1 this value. And then ESP. So this one I got correct after finding the right bytes for it, but what I intended it to be was correct. Okay, so that's good. Now let's go and figure out why the OR register needs to be EBP. I guess I did already fix that one. The SBB register, I've already fixed that. Let's at least check why this needs to be BH and not DI. Or compare. So we have 3D. Oh, because I said it's an 8-bit. Okay, that's fine. So why was this one ESP? The ADC. Where's the ADC? There we go. Oh, that one I got correct. So rather, why is 6E EBP? Did I mean to put in something else? And I just, maybe I just like intended it to be EBP and then forgot. I don't know. Okay, but I am getting stuff that matches now. Oops. Or, you know, my expectation in the test matches what the equivalent assembly result, disassembly result is with RASM. Okay. And then, yeah. DL. All right, let's see how much failed. Okay, well, the original tests are still passing, so that's good. And the SBB test seems to work. Then, no, SBB failed. So only the new, so all all of the new ones are failing. Yeah. Okay. Then this is line 75. This assertion that the register is EBX. Interesting. As well as 91. So I'm sensing a pattern so far, and 107. Okay. And I'm guessing 126. No, 123. Okay. So operand 1, the register is wrong, but the type is correct. So even when I've swapped them, so Let's look. We are getting, so let's see, for 75, we're expecting EBX, which I guess is 8, but we are getting 7, which is going to be BX. But we shouldn't have anything that's BX, right? 0, 1, 2, 3, 4, 5, 6, 7. Yeah. Shouldn't have anything that's BX because size 32. So this is the only way to get BX out of this. And again, it's like we should just have EBX. So 0, 0, 1, 1, 0, 1, 1. If size is equal to size 16, because I've put these in the wrong order. Okay, how did that not fail on earlier stuff? Let's see, everywhere I call it with W as the second parameter. Yeah, how did that like escape failing in earlier tests? Because we were, no, I mean we were using it on both of these in the earlier tests. That's interesting. That one's hard to square with. Let's see why. I mean, so if we have the register to register, we were just using 32-bit. So yeah, we should have done some of these, at least one of these with W. So if we do, let's see, sub, let's improve our test case since we've had a failure that was not detected, or a bug that was not detected. And we're gonna do 2B. Is that, yeah. So now we just want 2A, I guess. Reg2 to Reg1. And have it be 8 bits. So let's look at RASM results 2AC8. They are both 32 bits. Or, sorry, they're both 8 bits. So, yeah, that makes sense. Okay, so let's, and now that test is failing as well. Good, okay. Then I'm just gonna go ahead and swap the order here. That apparently did not matter. Oh, fix the sub one. Now we're getting different error. Now it's looking for 5. or it's calculating the result. So 0, 1, 2, 3, 4, 5 is BL, even though oh, maybe what I need to do is say it's always false on these. No, that didn't help. And that was on the register one. No, that was on the mod RM. Oh, sorry, it needs to always be true. For okay. That fixed the SPB one. Still got the wrong register for for the OR. Let's double check. 096E44 should be ESI. Yeah, okay. And we are expecting, we're getting 16. Getting DX. Oh, we're getting EDX, I guess. So this is the OR case. Yeah, why are we getting EDX? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. You just do like 5, 9. Wait. I'm already off. Wow. I'm just going to mark the 32-bit ones because those are the ones that will primarily come up. I guess we could also do the little ones. Oops. Okay. So we want ESI, but we are getting EDX. How could that be? And we are passing in 6E. We'll check in the table that, I mean, my recollection from when I was looking at it a minute ago is that that is correct to be an ESI displacement. So RM is 110. And we are in, so that was a displacement of 8. So yeah, so 110 or 01 in the mod category. And 110 is what we are passing in here. Should come back as ESI. So how is RM? Wait, RM needs to be 3? No. Oh. How is RM 3 bits? And we're doing and 3. I need this to be and 7? God, how, like, see, the problem of not doing comprehensive tests, I guess, is we were not doing stuff with these upper ones. So if we just use these lower ones, then the fact that we weren't including the high bit is failing. So mod should be the value shifted over 6. That's fine, because that'll give us the 2 bits. But this should be the value. RM is going to be the lowest bits, lowest 3 bits, which we can see here. Yeah. Okay. Weird that I was failing on that. And now they all pass. Okay. Wow. Cool. So let's take a quick look at how we might consider doing SIB. It's going to be another byte following the mod RM. And we should probably do that in a separate function, I guess. Just because there's going to be enough logic to justify that. And like in general, we should probably pull this stuff out and do it as its own function. Yeah, and so it's going to have some similarity. Thankfully, for the 32-bit stuff, we can reuse that reg bits piece. We'll have to special case this one because I'm not sure why they have none here. Where does it have the? So it's 4, and then there's a special case of the base being 5. Yeah, I'm gonna have to spend some time reviewing SIB, but in general concept, it's going to be relatively similar to what we were doing for mod RM, which we now have working pretty much. I feel like this code is correct enough, you know, skipping the SIB additional byte parsing work, correct enough that we could probably abstract, you know, like pull it out into its own function to decode the mod RM byte and then be able to reuse that on all of the further instructions that do mod RM. I don't think the way that we're doing this is in any way particular to the set of instructions that we're currently working on. So I feel good about getting that working. Let's see, git add debug.c, right, and 86.h. So I'm going to just start adding some stuff. We will deal with that later. But yeah, I'm going to commit all of this and push it up to the Git repo, which will be, it's linked on my channel info, and it's going to be linked in the VOD description as well. But I feel really good about the progress that we made on this. Like, there's a real set of actual instructions that this can decode right now. We've only got a very minimal test suite that covers the set of instructions that are actually decodable by this, but for now, you know, that's fine. And again, in a later stream, I will probably look into how I can expand the test capabilities and generate a much more comprehensive test suite. Make sure, because I mean, we already noticed some scenarios where stuff was coincidentally working, even though like I was not figuring out the RM value correctly. It happened to be correct for all of my test cases. So there's definitely significant value in, at least with the way that I've written this, there is significant value in having a comprehensive test suite. There are probably ways that you could refactor this, and like I could say, given an RM, a mod RM byte, write a function that says take a mod RM byte and return the RM value from it. And I could have written unit tests for that function, and we would have seen this much more readily with those unit tests failing. And then I wouldn't necessarily need comprehensive testing on the, like, from a certain design perspective, this can be broken down into smaller functional units, and the actual decode a single instruction thing is more like an integration test of all of those functional units that make up the different elements of decoding. Or, you know, I guess maybe not an integration test, but certainly a whatchamacallit. My brain is a little bit fried at the end of the day here, but when you do sort of an end-to-end test, so there's definitely that view in terms of how you might do the software development in your testing regime, and how the testing directs your factoring of the code. At the same time, you know, that's a concern that could be used to improve the readability and other sort of software design or software development elements of how the code is structured, but it has very little to say about the performance of that code. Granted, I'm not writing this for performance sake right now, but there's definitely a sort of like a low-level approach versus, you know, maybe if I wanted to rewrite this in, I've been writing some code in Clojure. If I wanted to rewrite this in Clojure, I would do a lot more little functions that would be testable. So I would absolutely have a function that takes a mod RM byte and returns an RM value from it, and another one that takes the mod RM byte and returns a mod value from it, and that kind of thing. And then we could write unit tests around those particular function units. And, you know, that would all be a much better structure from that sort of software development standpoint. I'm okay with what we have right now. in part because I don't foresee this becoming so large that the element by element sort of impediments of not having that better structure are going to become overwhelming. I don't think it's going to end up like a sort of death by 1,000 cuts scenario. If this was a much more unbounded problem where, oh, I could work on this for multiple years and just keep adding more and more features to it, then I would absolutely want to have a better testing approach and structure it and use the software development principles that are from like the sort of software craftsperson movement. But I don't know, this is going to be a very minimal library with a really specific focus instead of behaviors that it's going to implement. Like, again, I don't even think I'm going to go so far as to try to do anything with the 64-bit instructions and the Rex prefix and stuff. But basically, I feel like I know how large this project is going to get, and I don't want to rewrite everything to suit a different approach. That also isn't like ideal for C. It probably works a little better with a language that is just a bit smoother, maybe. I mean, it's definitely doable in C. It's just like this feels like the way to do it in C, and maybe that's purely a result of the kind of code that I have seen written in C. I might go for a better structure in if I rewrite this in Rust, but yeah. So for now, I'm gonna eventually have a comprehensive test suite and try to test every variety of the add instruction, every variety of the AND, XOR, sub, SVB, etc. I'm obviously not going to test every value of an immediate or every value of a displacement or something. Those are not, those, additional tests don't really add a lot. But yeah, I think on the next stream, what we're going to focus on is get the SIB code working. And then we've got modRM SIB behavior implemented, and we can start looking at other opcodes, I guess, and sort of go back to the drawing board on how we parse out the opcode and decide how to go from there. Because like this works well enough for the chunk of instructions that fit a particular block category in the opcode map, that sort of have this chunk and this chunk, and that's very convenient. But I don't think that it doesn't apply necessarily to these other instructions that are sort of fit in all these spots wherever they can be fit in. So, and then like move and stuff is just, there's a lot more varieties to them. So I'm probably going to have to come up with other ways of dealing with those instructions, and then eventually we will get to the 2-byte opcode instructions, 2 and 3 bytes, which are mostly more advanced instructions. What is this one? This is a Simdi instruction, so there's a lot of like Simdi instructions in the 2 and 3 bytes. I don't know why there's a V in front of it in here. Maybe that's the more official name, but yeah. So there's V versions for AVX, I guess, and there's a simpler version for SSE that I don't know, doesn't have a vex prefix. So I don't know if I'll even bother with these for a while, if I ever get to them. But these other simpler named ones, the C move, these read write MSR ones, sys enter, sys exit, sure, that's all fine. I don't know where syscall is. It's probably a 1 byte somewhere in here. Yeah, so, but the next thing is definitely the SIB. I just don't think that's going to take the whole next stream. So we'll start working on some additional instructions after that. Cool. Thank you for watching. I'm starting to have a lot of fun with this project, and tomorrow we will get back to working with Anger, finish up the final Anger CTF like instructional CTF challenge, and then we'll move on to the CTF challenges from the Nightmare course, which are in the category where Anger is probably the tool to use. So we'll see how quickly we can get through those. I have zero clue, like, if the stuff that I've looked at is, you know, so simple that the ones in a real CTF challenge are going to be, I'm going to be completely out of my depth, or not. I have no idea, but it'll be interesting to give it a shot. And yeah, and we'll come back and do more x86 instruction decoding stuff on Thursday. So again, thank you for watching, and I'm gonna end the stream now.